Alright, welcome to part 2. In this part we're going to learn how to name molecular compounds and how to write molecular formulas or covalent compound formulas. So make sure please that you have your periodic table with you for this part of the tutorial. So let's first look at how to name covalent compounds. So there's 3 steps basically. We're first going to name the first element. So that's just going to be the normal name of the element. The second element then we're going to take the name and change the ending to "ide", I-D-E. And then we're going to add the prefixes. And that just tells us how many atoms of each molecule there is. So in the formula, this will be shown as the subscripts. So there is a little bit of an exception there. There's no need to use mono for the first element, and I'll show you what that means. So that's just in regards to the prefixes. So what are the prefixes then? So these are our prefixes. So they just go before the name of the molecule or before the name of the atom, depending on how many atoms there are in the formula. So for 1, we have mono, 2, di, 3, tri, 4, tetra, etc. there. So the best way then to explain what I'm talking about is to show you with an example. So let's look at how to name covalent or molecular compounds using the following compound, N2O4. So looking at this, we can see if you look for the symbols on your periodic table, an N is nitrogen and O is oxygen. And we know that our subscripts tell us how many of each atom there are. So we have 2 nitrogens and 4 oxygens. So let's go ahead and name this molecular compound then. So our first step, name the first element. So we know that N is nitrogen. Our second step then is to name our second element. Now we take the root of the name, so oxygen, but change the end to IDE. So we would get oxide. We cut it down a little bit. It's not oxygen because that just doesn't flow nice. We want it to sound nice as it flows off the tongue, so it's oxide. And then lastly, we add our prefixes to show how many of each atom there are. So we look at our subscripts. So first of all, we have 2 for nitrogen and 4 for oxide. So let's go to our prefixes table then and look up 2, which is di. So we have di. And 4, we have tetra. So we go back and we add our prefixes. 2 is di and 4 is tetra. And then we put it all together. So N2O4 is dinitrogen tetraoxide. So let's look then at another example. Let's name the following compound, PCl3. So name the first element. So it's just its normal name, so P is phosphorus. Name our second element, changing the ending to ide. So our second element is chlorine, and we change the end to ide, so it's chloride. And then lastly, we have to check our prefixes. So our subscript here that we have is there would be a 1 here and a 3 we have here. So remembering if it's just our element symbol, that means that there's just 1 of them. So 1 is mono and 3 is tri. So 1 mono, 3 tri, and we get monophosphorus trichloride. Now, if you remember back a couple of slides, I said there was an exception, so there's no need to use mono for the first element. And it's sort of the same thing as there's no need to write 1 for the first, for the element either. But in this case, it's just the first one. If we have one of the first elements, there's no need to use mono. So what we would actually call this molecular compound is phosphorus trichloride. Just having the name there, we know that there's one of them. Now, there are a couple of exceptions to this naming system, and it's usually to do with hydrogen, and that's because it is quite a unique element. So many compounds that contain hydrogen have simpler names, or what we call common names. So for example, we have H2O. We know that as water. You could also call it dihydrogen monoxide. And then you also have CH4, which is methane, and NH3, which is ammonia. So just a little side note there. Alright, so let's now have a look at how to write molecular formulas from their names. So we're working with basically the same steps, but we're just doing the opposite thing now. So we're going to write the symbol of the first element, then we're going to write the symbol of the second element, and then we're going to add our subscripts from our prefixes. So let's have a look then at an example. So write the formula for the following compound, dichlorine heptaoxide. So step 1, we're going to write the symbol of the first element. So we have dichlorine. So our first element there is chlorine. So that's Cl. Step 2, we're going to write the symbol of our second element. So we have heptaoxide. Oxide is oxygen. Now, our third step is we're going to look at the prefixes so we know which subscripts we have to add. So we have di and hepta. So let's have a look then at our table, and we can go the opposite way now. We go look for di, and we see that di is 2. Then we look down for hepta. Hepta is 7. So now we know what our prefixes have to be. So we can now write our formula. So dichlorine heptaoxide is Cl2O7. So let's have a look then at another example, nitrogen monoxide. So we're going to write the name of our the symbol of our first element. Nitrogen is N. Write the symbol of our second element. We have oxide. So oxide is oxygen. So we have O. Then we've got to add in our subscripts. So we have nitrogen monoxide. So we know that there's just one nitrogen because we don't have anything in front. No prefixes. And our prefix on oxide is mono. And if we have a look here, mono is 1. So like I said, remember we don't write mono for the first element, but there is 1 there. Alright, so we also have to remember that we don't usually write down 1 as our subscripts either. If we just write the symbol, we know that there's 1 there. So let's go ahead and write our molecular formula for nitrogen monoxide, and we just have NO there. Now there are some special types of elements that we call, or that hang around as what we call diatomic molecules. So diatomic molecules are elements that do not exist singularly in nature, and that's because they're super highly reactive. They like to exist naturally in pairs, and this is because when they pair up together, they are more stable in a molecule than just as atoms on their own. So which elements then are our diatomics? So we have hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. So they all hang around in pairs, never by themselves, as they're too reactive to do that. So one way of remembering which ones are our diatomics is this little saying here. Hun, it's the halogens. So H-O-N, so hydrogen, oxygen, and nitrogen, and our halogens are our diatomics. So here they are. Another way of remembering it is our hydrogen and also our halogens, and they make up a 7 here. So we have actually 7 elements that are our diatomics, and they make our 7 plus our hydrogen over here. And another little way of remembering which one our diatomic molecules are is this little saying here. Have no fear of ice cold beer. We have our hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine. Alright, so I'm going to leave part 2 here and click on the next video for our final part 3.